Okay. So if you want to, as always, you can just, there's only 2 E's in there, Jeff. There you go, buddy. Add this to your old formula sheet so you can make a brand new formula sheet, whatever you like. It's not really, well, chapter 8 is going to have all the formulas, 5 formulas from chapter 8. There's the 3 confidence interval formulas. Right? And then there's the 2 formulas for finding the n to be such and such confident, right? Whoa, dude. All right. So we got this one here. Let me go like this. Right? Got this dude, and we got this dude. Okay. Now, you'll notice, did I do that to you? I don't think I did. You could have a formula here where instead of z, there's t, because you don't know sigma, so you have to use s. Right? So, I mean, if you want to, it's the same idea as here, right? If you have to use s instead of sigma, you have to use t instead of z. It's the same idea. That's t's job, right? Is to cover things when I don't know the real sigma. All right. So that's chapter 8. And then chapter 9, if you want to, you can put down this formula. It's really nothing new to it, right? You can also put down, here, make this a T star. So are you with me? So that's 1, 2, 3, 4 equations there, right? Don't smoosh them all together. You guys with me? And then, of course, the new one, the new z-star formula that we never saw before was for percentages. There. Any formulas you think I missed from chapter 8 and 9? Okay, let me talk just a little bit about chapter 10 in case anybody wants to look at that. Just real quick. What chapter 10 does is, for example, if I wanted to test a drug, brand new drug like the vaccine, I want to test vaccine. So was there an old COVID vaccine before we invented the COVID vaccine to compare it to? Did we have like a percentage I can check? Like, we think the new COVID vaccines, but no, there was no such thing as a new COVID vaccine, that we created a COVID vaccine, we never had one. So I'm not going to have some known previous thing. And so how do you test a vaccine? Well, we're not going to get into how do you test a general drug? What do?
You have people take it.
Have people take it. And you have some people
Not take it.
not take it. Instead, they take a placebo. So they think they're taking it, correct? You with me so far? Right? Is everybody with me? And of course, you would normally have a control group, but it's sort of out of our reach with 3 groups. So we're going to do 2, right? So I'm going to have 2 samples, which is new. Chapter 9, we only ever have 1 sample at a time. And we compare it to some previous amount or whatever, right? Some mu that we knew before. So chapter 10 is going to have 2 samples. So whereas this formula has 1 sample, mean, and 1 sample, I can't remember which, screw it, I can't remember which section I assigned. Was it 10-1 or, wait. I think it was 10-2 I put down there, right? Bum, 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 bum. Can't remember if I gave you the T1 or the Z1. There it is, Z1, okay, even better. A sample mean with 1 standard deviation, yes? Okay, so what chapter 10 does is it says, now I'm gonna have, so this is chapter 9. Chapter 10 says, oh, now I've got X bar 1 and X bar 2. I've got 2 means to compare. I don't have a mean to compare to a known amount. Are you guys roughly with me? Like the whole Ford thing, Ford changed their assembly line, whatever. And this used to be the mean, and now it's this. Well, we don't have that shit. We have 2 samples to compare. And if I have 2 samples from 2 populations, I might have 2 different standard deviations. So really, the Z-star formula just kind of gets bigger. So watch what happens. Let me see if I can do this semi-quickly. Do you guys agree with me that this is the same as, I don't know why I put a little 1 there, sorry. Does anyone have any problem with me doing that? What's the square root of sigma squared? Sigma. And square root of n is square root of n. Hey, it's the same thing. So watch it, this just doubles. So now I'm going to have 2 samples. They could be different sizes, and they could have different standard deviations from the populations. So it really is the same formula. I'm almost certain somebody's going to be like, no, Jeff, it obviously isn't. And I'm going to stick by, it's the same damn formula. So this would be what you would use in the 4th step in section 10.2's hypothesis test. It's still all the same 5 steps. All right, that's all I'm going to say. So if you feel adventurous and you want to try section 10.2 out and you have some questions, feel free to ask. Yes?
So is chapter 10 going to be on the test?
If it is, it's only going to be in the bonus section. In fact, let me just say this. I will have 1 question in the bonus section from section 10.2. So that if you do this homework for extra credit, you'll be more ready to do that for bonus points on that test. But again, it's up to you. It's your choice.
We don't have to do the chapter 10.
You do not have to do section 10.2 homework. It is extra credit.
Is there section 10.1 or 10.3?
Is there?
I think
No.
there's 10.
So yeah, it's only 10.2 on the homework sheet. That's the only part we're going to do. Okay, I like it. I like it. Anybody upset about that? I'm sorry. Okay, all right. They're like, dude, you could have done this any damn time you wanted to. Okay. So we got a formula sheet. This is there if you want it. If you do it and you want to add this to your formula sheet, feel free. If you think you're going to do that extra credit homework and you want to have this formula for you, go ahead and put it down there. Yes?
Now will chapter 10 be on the final?
Maybe. I don't know. If I do again, if I do, it'll be in the bonus, right? It'll be so evil for me to go, and the final's like, do this, bro. No, that would be more evil than I currently am. I think I am more evil than I was 10 years ago, but not quite there yet. I'm working on it. Okay, so what that means is it's wide open now. So if you have not been keeping up with the homework, you might not have many questions, which is really bad. So if you're in that situation, you might want to try start doing some from the practice test. if you have done some homework and you have questions, let me know. If you have general questions, if you want to do another example of something, if you still don't understand some aspect of hypothesis tests or confidence intervals, right? Just ask away. Yeah.
Would you like that one example we did the other day? I still don't get that.
Say again, sorry?
We did like a worksheet the other day, and we didn't complete the back.
Oh, yeah, all right. Was it the one about 4 week stats? So we did the one Chicago police, right?
Yeah.
Okay. So there is the other side. Anybody not have that handout about the Chicago police? On one side, and the other side it says passing a 4 week stats course. Okay. So it's a good idea. Let's do that real quick. Where are you at? There you are. Sure. All right, so we did this side, the one about Chicago police and all that stuff. So let's take a look at this side here. Turn the sun off a little bit. Good precious sun. All right, so yes. Oh, thank you. Camera, the hell's your problem? I should have paid extra for the one that follows where I'm going. Let's see. There you go, little dude. Okay, so read through that. The very first thing you care about is just what is the claim that's being made. All right, who's got that? Who's found the claim? They're not using a code word or anything. They actually use the word claim. So, what's the claim?
At most 55% of Chicago residents.
No. We did that one already. Sorry, Maddie.
Oh, wait, which one?
We're doing the other side.
Oh.
No worries. Yeah, so the claim is right here, of course. That's the claim that the proportion is not the same as 84.5%. So, proportion not the same as 0.845. So, remember, percentages are an extra thing that we humans invented. So whenever we want to do math with these things, we have to change it to decimals. It's one of the most immediate mistakes people make, is to not change things to decimals. So that's what gets every hypothesis test off the ground. That's why a hypothesis test exists. If there was no claim, why would a hypothesis test exist? So it gets things going. Where does it go? I'm going to update these old worksheets. In the ho or the ha? So what has to be true to go in the null hypothesis? The statement must have an equal sign. This has the exact opposite of that, correct? So where should this go?
In the hot.
In the hot. Do you guys understand? Is that right? This definitely doesn't have an equal sign because it has the not equal to signs, the complete opposite of that. So what are the things that could go into the null? Something with a greater than or equal to, something with a less than or equal to, or something with an equal to. Those are the three things that could go
Throw home.
into the null hypothesis. Let me be careful how I say it.
Isn't it hot
What do you mean?
for the null?
No, the null is ho. It's H-O. Yeah. And the ha is alternate. H-A is the alternate.
Oh, okay, I got you.
So, this one does not have one of those three things. So what's the ho gonna be?
Does equal.
Yeah, P equals. It's gotta do the opposite of what I just wrote down. So let's do this for ourselves. This one is the claim, yes? Okay. I don't care that that's the claim again until the end. Now, why did I word part B the way I did? How am I being nice on part B? What do I normally ask on part B? Z or T. And why I am being nice. What is true about NPQ problems? They never use t-scores. So we can see that from right here, right? There's two x bars, ZT, and then there's, P's only has Z. T's were invented for means. I don't need to use t-scores with P problems, with percentage problems. So what do I have to check to make sure I can use Z-scores? How do I check to see if it's normal? Say again, sorry.
NP has to be greater than 5.
Yeah, NP and what's N? 322. And what's P? You have to do no work at all. I've already written it down. 0.845. There you go. So what's Q?
155.
Yeah, 155. Right. So together they gotta make one, so you just do one minus the other one. And we pretty much know this is gonna come out to be, but just do it for me. What does it come out to be? Definitely bigger than 5, but maybe just be a little more specific. Whoops. Equals. Anybody? 272 point stuff,
Point zero, very small fraction.
and that's grade equal to 5, and this will be 49 point stuff, which is at least 5 check. Good, yeah. Oh shit, and a half. What have I done? Okay, thank God. There we go. So steps are always the same. The first step is, what the hell are you talking about? Second step is, why are you allowed to talk about it? Right? There, we're allowed to, because it's normal enough. Part C then, the third and fourth steps are the most important steps. Part C says, how far away is far away enough to show evidence that it's not the mean they think it is? Maybe? No? So again, the null thinks it is 0.845. So the null thinks it's in here somewhere. And I didn't ask earlier, but how many tail tests is this going to be?
2.
Because not equal to means it could be less or greater, right? To show it's not equal to something. So now if I find a sample, so if it does equal this, I should get a sample that's close to this. if my sample is far away from that, how far away? Well, that's what we're about to define. We're about to define how far away is far away enough. Just like earlier this semester, we defined it to be 2 steps away. Now we're going to be a little more sophisticated, right? Just to say that way, just because. So how do I figure out what those z-scores are defining my rejection region? What do I have to know?
The z-score?
Well, to figure out the z-score, what do I have to know?
What the percentages outside of?
Good, good. And what does it tell you up here somewhere? No? Oh, I see, east side. So just say 0.10. So it's 0.10, 2 tail, z-score, right? So can you look that up? Alpha's 0.10, 2 tail, z-score. Can you guys look that up? And of course, you're looking at the t-score chart, right?
No.
Good.
1.282. It's 1.282.
1.282? Did you look at 1 tail or 2 tail?
It's 0.10, 1 tail.
But how many tail tests is this?
Okay.
Okay. So I want that to make all the sense in the world.
645.
Yeah. We know it's a 2 tail test. We know alpha, so it's that easy. 2 tail test, 0.10, z-score, so I just won't stop 1645. Bam.
How do you know if it's, 1 or 2 tail?
Why was this one a 2 tail? Anybody?
It wasn't equal to, which means that it can be either side.
So if you think something's not equal to something else, you can show it's more or you can show it's less. So we have 2 directions our sample could show up in.
What if the claim was equal to?
HA would still be. So I don't care what the claim is. I don't give a shit what the claim is. I don't. HA is not equal to. HA is the thing I can show evidence for. How do I show evidence something is not equal to something? Either I show it's more or less. If HA said P greater than 0.845, ah shit, now I'm one direction, right? Not shitty man, but there's only one direction that'll show me evidence. What's up? Yes.
So if the HA is not equal to or equal to, it'll always be 2 tails.
HA will never be equal to,
Okay.
because it has an equal sign, it's an HO. So if HA is not equal to 2 tails,
Alright.
bam. Because otherwise HA is greater than, in which case your tail is up, or it's less than, in which case your tail is down. I desperately want this, obviously I want this to make sense. But how do I show? Again, HA tells me where evidence is going to be found. Not equal to means it could be way smaller or way greater, and that would show me it's not this. That's all I care. I just want to know if it's this. I just want to show it's not this. So my sample could either be way down there. Well, that's a hell of a lot. Or it could be way up. Holy shit, that's good. If it said greater than, my sample can only show up above to be evidence. If it shows up below, I'm screwed already. I'm not going to do shit, right? I think it's greater than 7. My sample's 5. Well, I'm not going to do shit. I'm not going to do that test. I'm already screwed. Okay, maybe. So can we put this into words? If? Huh? C star? How do I get in here? I have to be greater than. How do I get down here? So if my Z star is more than 1645 away in either direction, right? Then what can we do? Whoever thinks it's supposed to be, if I get there either way, whoever thinks it's supposed to be here, they look to be wrong. Do you guys agree with that? Just right there, just on that much. Right? HO thinks it's here. So if we find stuff here, we can reject HO. Because he's saying crazy shit then, right? Maybe. So if we, that's why this is called the rejection region, because if you get into it, you reject the null, which also at the same time means you support the other guy. If you reject what the one guy says, you can support what the opposite of that guy says. So step C sets up where evidence will start. And then step D is, all right, did we get there? Right? Step D is, where did our sample end up? How far away did it get? So what is, so we know N is 322. We know X, 282. So we got 282 out of 322 is something. Shit, I went the wrong way. 0.8757, so 876?
Yeah.
Okay. It was a 50-50 shot on which way to go from 875. Let me stop for a minute. I still, every now and again, I'll look out there and I'll see something like, but you're not saying anything. So today's a great day to go. I still don't understand what the hell you are doing on this step, right? So, okay, all right. Go ahead and do Z star, please. You got everything you need. Figure out what Z star is. All right, Doctor. What goes inside the square root?
0.845
Good.
times 0.155 divided by 322.
So you can see acid.
I feel like I'm lost for some reason. Where do we get 0.876? Where's P hat again?
All right, so it's, I really want this to make all sense. Where's the sample? Where do they discuss the sample in the problem?
I think I read it.
So it's always gonna be, you look where they're talking about the sample and you say to yourself,
Yes.
what out of what? You're always looking for something out of something. Now, some of the problems in the book actually calculate P hat for you. They'll say, in a survey of 322 stat students, 80% of them said this, so they are kind of already calculated for you, so that's nice. Yeah. So what do you guys get for this?
One point five three seven.
Say again, sorry.
1.537.
1.54?
537.
So 5.4? Sorry, man. Why, do you agree? You would round it there? 1.537, is that what you said? Okay. And of course, why am I rounding there? Because the chart I'm gonna use to look up my p-value only goes to 2 places, right? Okay. We're gonna have this 1.5, 1.567. Alright. So if we look that up, oh, by the way, We already know the answer to the test, right? Before we even look at the p-value. Did we make it far enough?
No.
Wah, wah, wah. Too bad. Yeah, so we failed, but let's look at the p-value because that is the amount we would report in our write-up if we were gonna submit this to a journal somewhere. What am I looking for? My z-score chart. Do you guys find that? There we go. Anybody? So it's gotta be the area in the tail that our z-score makes. Here's our z-score, so it's gotta be this area. Of course, when you look up 1.54, you're gonna find the wrong side. So you just gotta do 1 minus that.
So we look up the area on the z-score chart and then do 1 minus the area.
Yeah, because the area on the z-score chart is gonna be below. You want the area that's in the tail. And then we still have to take care of the fact that this is a two-tailed test, right? Two-tailed test. So anybody got that? So here's kind of like the picture that goes along with this. I want this area here. Anybody?
10618.
Yeah, 0.618. And then do you remember what to do since this is a two-tailed test? Yeah, so the p-value equals 0.1236. We're going to multiply this by 2 to make it fair. Okay. So another way to say this test is since the p-value is greater than alpha, we fail to reject the null. Now, last time, I did a piss-poor, pitiful job of trying to explain the idea behind what I just said. So let me see if I can do an even worse job here. Let's see. So let's say this is my rejection region, right? Let's just pretend like this is a rejection region, yeah? If my sample is here, did we reject the null? You can do it, come on, not a trick question.
Yes.
We made it, right? We made it. Is the area in my tail that my z-score makes, how does it compare to alpha? It is smaller, of course. So if our p-value is smaller than alpha, that means we must have made it into the rejection region. So p-value less than alpha, reject the null. If our p-value is greater, that must mean we didn't make it in, because then that's the only way our tail could be bigger than alpha, than the rejection region. Yes, maybe?
Yeah.
All right, I'm going to go with it. Okay. And this is why, again, alpha pretty much only exists for real in class. Outside of class, you develop your own alpha on the situation. So that's why in articles they report p-values. I've got my own alpha, I compare it to that. I'm like, that's not good enough. Well, that's all right, right? No, I don't know if you guys get that at all. Yes?
So in the homeworks, there's, I think, like 2 questions they don't give alpha.
If they ever don't, you assume it's 0.05 because that's the most often used one. Okay. So if they don't tell you what alpha is in the homework, you assume it's 0.05 because that's the standard one used.
Out of curiosity, for the p-value, did you take 0.0618 and?
Double it, yeah.
Oh, you
Because it's a
doubled it.
two-tailed test, yeah.
Okay.
So we could have cut alpha in half, which is what I wish they would have done. But since we didn't cut alpha in half, we still keep it at 0.10. We have to double the p-value to make it fair to compare. Again, I'm not sure if it's a very kind of detailish thing there. So what is our conclusion? How will it start off? If we succeed? No, we suck. So we have actually, before I do this, what was our claim again? Which one? Which hypothesis statement?
P does not equal 8
No.
point, okay.
O or ha?
Oh, huh.
Ha. So then I'm going to use this language, not that language. People are always like, how do I tell? It's that simple. You want to talk about your claim. We didn't make it far enough away, so we can't support the alternate hypothesis.
So, just real quick, like I understand that, but if p-value was less than the, thing,
If the
what
p-value
would-
was less than alpha, we would reject
and support
the whole, the null, and we would support, yeah.
Okay.
Rejecting the null is the same thing as saying supporting the ha. It's like me saying I'm twice as old as you, or me saying you're half as old as I am. I just said the same thing twice. Yeah. Okay. Which unfortunately nowadays is more and more likely. Now, we have not found sufficient evidence to support the claim. Right, just using that language. Fail, we have not found sufficient evidence to support the claim that, what do you do now, kids? Plagiarize. The proportion of students is not the same as 84.5%. The percentage of students who agree passing 4-week stats course. Oh my God, there's so much shit here. And remembering shit. Yes, I'm gonna write. Is impressive. Is the same as, my God, Jeff, this is a long one. It is the same as the percentage of professors. Oh my God. Okay. That's a lot. That approximates English. Gonna need a Rosetta Stone in the future to understand what I was writing. Gotta sign up for some Babel lessons to read that stuff out. All right, that's enough. So I mean, doing a percentage hypothesis test versus a means hypothesis test are the same thing. Do you guys agree?
Yeah.
I mean, there's slight changes in the formula we use because we have to have a formula of freaking p's in it if I have a percentage wrong. But fundamentally, all the steps mean the exact same thing and they all feel the same. Yeah. Okay. So now, remember, we also have confidence intervals on this test. So if you have any leftover questions about confidence intervals, if you want to try a problem out for the practice test,
Real quick, what is like the key things to look for? I'm still confused with knowing if you're gonna use a Z-score or a T-score.
all right, so what's the first thing we always look to see if we should be able to do anything?
It's normal.
See if it's normal, right? So that could mean different things in different situations. Either they say it's normal, and then I don't care anything else, it's normal. Or sample size greater than 30 if it's a means test. Or NP, NQ greater than equal to 5 if it's a percentage, right? So all those are doing the same thing, checking to see if it's normal enough. And then, once I see it's normal enough, what differentiates? What's the one thing I look at to differentiate between Z and T?
If it's a sample or a population.
Be more specific. I'm always going to have a sample.
Mean.
No.
Okay.
Slightly adjusted on
Yeah, look right here. This formula is going to stay here. Z's goes with sigma, T's goes with S. So if I know the population standard deviation, use a Z-score. If I only know the sample standard deviation, T-score. What would I use if I knew both?
Z-score.
Shit, yeah, that wins. If I know sigma and I calculated S, get out of here, S. S's job is to approximate, I really want you to understand, S's job is to approximate sigma. So if I have both, what is that doing here? I'm going to use sigma, right? I'm not going to use the estimate for the thing that I know. So there are several homework problems, maybe 2. They gave you both. You just got to realize, if I know sigma, screw S. Right? S's job is to estimate sigma. So why would you use it if you knew sigma? Does that make sense? No, maybe? Okay. All right. Nothing's made sense since the syllabus. Oh, shit. Anything else specific or general? It's wide open now, so we can, I don't know if you're looking at the practice test even. Just get a feel for what kind of weird stuff I can ask you. I might, do you notice how on number 4, I have all the 5 steps? And on number 5, I don't, right? All right, but you know the 5 steps is they're in number 4, so. Okay, so I will give you at least one problem where I give you all the 5 steps.
We can just
I
reference
did not
that.
do all the 5 steps. I did not do all the 5 steps in the other one. It doesn't have.
Well, that's bad, you'll lose points for whatever step. I'm gonna
Let's do-
split all the points up between the 5 steps. If you leave out a step, you're gonna lose all those points.
Let's do number 3.
Yeah, that's a good one. What do you guys think? That's a confidence interval problem where you gotta calculate your own stuff. So first thing I want you guys to do is calculate what we need. Right? How many confidence intervals do I need to make number 3?
2.
2. And in order to make confidence intervals, I'm gonna need X bar, I'm gonna need standard deviation of some kind, right? So how do I do, I've got 2 samples from 2 different populations, yes? One population has passed the class, and I got a sample of those. Other populations failed the class, got a sample of those. I wonder if this is a service message from, public service message from your weird ass stats teacher. So, go ahead. Let's look at past the class. How do you figure out all the stuff we need?
Add it up and divide it by.
No. We're better than that.
Put them in our calculator,
Put them in the count, in where in the count?
staff.
In the list, and then do one of our stats. Because Maddie, real quick,
Yes.
nothing was wrong with what you said, but then to get the standard deviation, do you really want to?
No,
No, you want to let the calculator do
I
that.
sure don't.
Okay. I can compare what you get to what I got earlier. Let's see, past chapter, what it is doing. Oh yeah, good. Just to give you a little clue, when you do one of our stats, it does tell you n. Just make sure that it matches up with, count them, right? If it says n is 14, there's 15 there, you're like, I forgot one, shit. All right. Has anyone got the past the class data? What you got?
X bar equals 7.63.
Yeah?
Sigma equals 1.15. The number is 16.
Okay. And what the data you put in the calculator, Was it a sample or was it a population?
Population?
Where does it say that?
Wait. I was just guessing.
So read that first
Two
sentence.
different
They're two
populations.
samples, right?
Oh.
So these are just samples from those two things. So the calculator will always give us both sigma and s because it doesn't know what you put in. We know we put a sample in, so what do we have to use?
Wait, this is,
I really want this to make sense. Calculator's dumb. I don't know if you guys agree with me, but it is dumb as shit. It can't do anything until we make it do something. It is dumb. It's gonna give us both sigma and s no matter what we put in there. Because it's like, you gave me I don't know what that is, human. Here's everything. So we're the humans. We put samples in there. We better pick what? We better pick frickin' s. We can't take sigma because it's not a population.
wait, where does it say it's a sample?
First sentence. Right, is that cool? Okay. So therefore, I like your mean, 7.63, but then S is 1.146, is that right?
Yeah.
And then N is 16, I like it. Oops, I'm showing a little too much. Now, I've already done the next step, it's too bad for me. Oh well. But why did I look at the degrees of freedom? Because I know I'm gonna have to make a confidence interval. Why am I gonna use a t-score? Yeah, S, two things. N is only 16. Why am I gonna do anything? Can you just put down here, can't do it, Jeff, too bad.
It says, it is
Oh.
known that the populations are normally distributed.
Oh shit, it's normal, so it doesn't matter what the N is. I could have picked 2. Anyway. Is everybody with me? So those are all still in play. I still have to know if it's normal enough to do it. So even though N is only 16, it does say normally distributed, right? So look up the t-score for this. I want to be, what is it? 95% confident, right? So you can look on the t-score chart. You have a two-tailed test with 5%, right? And you want to stop at 15.
2.131.
Let's see what past Jeff put down here. Yay, I put the same thing. Okay. And now what formula are you guys going to use? Which one? The one's got T, yeah, you can use this one. So go ahead and do it. Do that. Make that interval. Pretty dumb game show. I can make that interval with 5 data points. I can make it with 4. So another real easy mistake to make is I'll see people put 15 instead of 16. Well, the formula needs n, right? So, incredibly enough, we would do all the same work to make the confidence interval for fail the class, right? So we would delete the stuff out of L1, we would put all the fail the class information in, and you should end up with this. And then of course, N is different, so the T is gonna be different, yes? Something to be careful about. And then you end up with this. Now here's the big deal. The real question is, do your results show that, how did I say it exactly? Do your results support the idea that the population means are different? I should have said yes. I don't know what that one. Yes, they overlap. No, they don't overlap. So wait, let me say this better. There's no overlap. That's fine. But what does that mean? Okay, so I'm kind of giving that away. There's no overlap between those two intervals. So what? What does that have to do with anything? If the means, if this was going to show evidence that the means are the same, what should the intervals have done? So for this first interval, for people that pass the class, it looks like the mean, that 7.02 to 8.24 captures the real mean, yes?
Okay.
And fail the class, it looks like 4.07 to 6.07 hours of study captures the true mean. Can you guys see that that is evidence that the population means are different? Because they do not overlap. The intervals themselves, do they seem to say that the means could be the same? No, they don't overlap at all, do they? One goes from 4 to 6 roughly, and one goes from 7 to 8. No overlap. That is evidence that they're different. So there's no overlap. I just forgot to say. That means that yes, it does support that they are different. And by the way, I mean, I've got the answer key for this, so you'll get all this stuff in a minute. So if they had overlapped, does it make sense if they had overlapped? Then that tells me that the means could be equal because there's a little space in which they agree. The mean could live in there. Okay.
Yeah.
Here, there's nowhere the mean can live in both. They're completely separate. Okay. So that's a good choice because I had a lot going on. You gotta remember how they do one bar stats. You gotta remember take the right thing out of the stats. Okay. Anything else you guys want to discuss? You guys okay with type 1 and 2 errors and stuff like that?
No.
Yeah, let's take a look. There is a problem. Huh?
Please explain how one is errors and not understand.
There's this one. So, when we do have okay, here's a really good example. Let's go back to the court case thing. I think I said this quickly, we really didn't talk much about it, but in a court case, what is the null hypothesis for a defendant?
I did not do it. Oh wait, the defendant?
Yeah, innocent.
I did not do it.
Innocent, right? The null hypothesis is innocent. Yes? Because what is the prosecution trying to find evidence for?
Guilty.
Guilt. They're trying to find evidence for guilt. And what's the within a reasonable doubt? How does that translate to what we do? Within reasonable doubt in a court, what does that connect to?
Physical evidence.
Alpha.
Oh.
You guys with me? Maybe. And why would alpha change? Well, if you have a different jury, wouldn't different levels of evidence sway different juries? Okay, I like it, which is why I'm a proponent of making every jury a collection of judges instead of crazy ass people. Yeah, okay. That's just. So type 1. So type 1 error is we reject the null when it's actually true. So in a court case, if the prosecution finds enough evidence, what is the verdict? Guilty, right? I like it. So but what if we say they're guilty when they were actually didn't do it? Has that ever happened? Have we ever heard of that happening? Yes? Yes, we've all heard of that shit happening. So, there is a reality that we can only find evidence for or not enough evidence for. We very rarely really know the reality. Yes? And this is another reason I love stats, because it's so freaking true to life. That is life. We don't know the reality. That's why there's these errors. So in a court case, even if they find enough evidence to say they're guilty, is there a chance they aren't guilty? Of course there is. So they would have made a type 1 error. They rejected that this person was innocent, when in reality, they were innocent. That's an error, yes? So the type 1 error is reject the null, but the null is true. So if you want to say it's shorter, reject a true null, right? Isn't that a mistake? That's not a mathematical mistake. That's just a probability mistake. That's just, we do the best we can. That's what humans do. So, for number 4, what is the null in, well, we didn't do number 4, but can you guys really quickly see what's the claim in number 4? Here. Yeah, it's a mean, right? Not equal. What's the claim? I don't use the word claim, but there's still a claim, right?
Less than.
Yeah, supposedly brings relief in less time. That makes sense. Why would I make a drug, like a headache drug? Yeah, it takes twice as long to work. Do you think anybody would buy it? Does it cost less? No. Get out of here. So the claim is the mean time to relief is less than the other one, 16.1. So where does that go? I'll tell you where to put it, Jeff. Up? The hop. I like it. So what's the hook?
More than or equal to.
11. Now, a type 1 error is we think the opposite of the null, when in reality, the null. So what's that mean? Type 1 would be we think what? We think the null is wrong when it's actually right. So what do we think? We think the mean is
Greater than?
no, because that's what the null says. So we think the opposite of the null. We think the null is wrong, but in reality, the null is right. So what do we think? We think the opposite of the null. Isn't the opposite of the null in the alternate? Yes? So what do we think? We think the mean is less than 16.1. Right? We think the opposite of what the null says, when in reality the null is true. That's what a type 1 is. We think the null is wrong, but in reality it's right. You guys, that's all it is. That's what type 1 error is. So we think the mean is less than 16.1 minutes, when in reality it's at least 16.1 minutes. That's it. That's a type 1 error. A type 2 error is just the other way around. A type 2 error is we failed to reject this when it's actually false. So we think this, we think the mean is at least 16.1, when in reality, it's less. Those are the only mistakes we can make at the end of this thing. I mean, if we do all the math right, those are the two errors we can make, just because life is uncertain. Life is unfair. Okay, all right. Hopefully that makes sense. So that's like the court case thing, right? What do we do if we don't find sufficient evidence? If somebody's not found guilty, what are they found? If you don't say they're guilty, you say they are not guilty. Because you never accept the null. We don't say they're innocent, do we? We say they are not guilty, which is different from innocent, believe it or not. That just means we didn't find enough evidence this time, right? Because they might be guilty. The prosecution just didn't make the case. Okay. I'm trying not to talk too much about the current stuff going on because, anyway, I don't know how you guys feel about it. Not making as good a case as they could have. All right. I don't even know. Do you guys know there's 2 big court cases happening right now? Yes? Okay. All right. Does that make sense? Anything else about that? No. Good. All right. Let me give you the answer key. One time I did this, and the students were like, "Did you handwrite each one of these?" I was like, "Yeah." No, I did not. I could just copy and color. So I really want everybody to really understand that. You come here on Thursday and everything's shut down, yes? And tutoring is shut down. There's no online tutoring either. It's just a pure, complete holiday. Woohoo!
I did not know there was 2 big court cases going on.
No?
No, what are they?
All right, there's one about Rittenhouse. I don't know if you know Kyle Rittenhouse.
No.
All right.
Evidently I
They're
know
both
all
related
of
to
this.
reasons. One's related to something that happened during a protest, Black Lives Matter protest, and the other one is actually one of the reasons why the Black Lives Matter protest occurred.
Oh.
Yeah.
Oh, I know about George Floyd.
No. This
Oh,
is
okay.
Ahmaud Arbery. George Floyd is over.
Okay.
Hopefully. Although we're going to have to probably live through an appeal, we'll see. Anyway, and again, it should not be political, but it is. So I have to not talk about it too much.
Yeah.
It's
Ooh.
very sad that certain things are political now. And
Yeah.
Anyway, I'm going to get in trouble. The dean's going to see that. Fire me.
Okay, I asked.
Well, I am a firm believer in trying to keep my own opinion out because I don't want to influence anybody and I don't want anybody to say I'm trying to influence anybody's way of
Yeah,
thinking.
100%.
So statistics is beautiful to me because I try to give you enough information so you can critically analyze stuff on your own.
So we just talk about chocolate milk and brown cows and.
Yeah, exactly. And Brussels sprouts instead of police brutality and stuff. Yeah.
All of that.
All that. Yeah, you guys are cool. If you're ready, you can go. So I love this awkward that you're all like, just get up and walk out and see that. Today's review, so it's all